Welcome to the Module 6, Lesson 8, Debrief questions. Now, in our application problem, I asked you to think about these two line plots. Now, this line plot is measuring 7 students and how much time they spent watching TV over the weekend, where this one measures 30 students and how much time they spent watching TV over the weekend. So the question asks, why does having a larger amount of data, 30 students versus 7, help us get a clearer understanding of the data? Well, here's the reason. If you look here at just 7 students, is it clear that more students watch 2 hours of TV over the weekend than any other time on the line plot? Yes, but it also looks like the same amount of students watch 3.5, 3, 2.5, 1.5, and 1 hours of TV. So with 7 students, this is the most popular. These 5 are exactly the same and the least popular. Now, if we look down here, 2 hours of TV being watched over the weekend is still the most popular by a large amount. But if we look at all the rest of the data, it paints a bit of a different picture for us. We know that 1 1/2 is almost as popular as 1 hour and 2.5 hours, but it's 1 person more popular. So the rest of the times aren't equal, they become to be a little bit less and more popular. They're still pretty close to each other. 2 people watched for half an hour, 4 people watched for an hour, 5 people watched for an hour and a half, 4 people watched for 2.5 hours, 3 people watch for 3 hours, and 2 people watch for 3.25. But this gives us a more accurate look or a clearer understanding of how many people actually spend this much time doing this activity. And if we interviewed 100 people, it would become even more accurate. The more people you interview, the more people that you survey, the more accurate your data is going to be, because it represents a larger amount of people, a larger amount of information to get your point across. If I interviewed 1 person and said, what's your favorite color, red or blue? And they said red, well then by that one survey, 100% of my people interviewed liked red, so therefore everybody in the world must like red better than blue. It's not very accurate because I only interviewed 1 person. The more people I interview, the more accurate my understanding or my data will tell me. Now, our second question says, why is it important to make each X on a line plot the same size and the same distance from each other? So push these aside for a second. Here's a line plot. This line plot represents the time spent learning math. Okay, it's representing it in hours. 1 person spent 1 hour, 2 people spent 2 hours, 2 people spent 3 hours, 1 person spent 4 hours, and 11 people spent 5 hours. Is this a very accurate way to represent this data? No, it's not. Because here, 1x is bigger than 2. 2x's is bigger than 2, but 1x here is bigger than all of these x's. And then this, they're so small, it looks like 11 people take up about the same amount of space as 1 person, and it doesn't keep going on in a straight line. It wraps around. It's not a very clear picture. If we drew this where all of our x's are the same size, just by one quick look, you could say most popular, least popular, these are the next, right in the middle. But here, you can't look at it and say, really quickly, I understand which is the most popular and which is the least popular. So by having your x's the same space from each other, I can see very quickly that this is the tallest column. So if they're spaced the same and they're the same size, I know that the higher the column, the more popular it is. The shorter the column, the less popular it is. Here, our tallest column only represents 1 person. And here, 11 people is equal to 1 person's vote. So this is not a good representation because you can't just look at it and see the information accurately and quickly. Keeping things consistent shows the data in a more precise manner. I hope you enjoyed the lesson. I'll see you next time.